Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Well guys, welcome back to our machine learning class. And this will be our last class of our machine learning course. In this class, I will guide everyone to complete a comprehensive case together.
Let's work on the body posture prediction project.
Let's quickly get to the point. First, let's take a look at what the project we're going to work on today is. As a type of wearable device, the sports waistband has become increasingly popular among people. The sensors in sports waistband has captured various data, such as whether the wearer is moving or stationary, the strength of the surrounding magnetic fields, temperatures, and wearer's heart rate, blood pressure, and more. Once a large amount of data collected by the sensors in sports wristband is obtained, it becomes possible to analyze and model the data by evaluating the numerical values of sub-features attribute. It is possible to determine the user's physical condition. Based on the user's condition, more precise and the convenience services can be provided. In this example, data from 5 users
A, B, C, D, and E
wearing sports waistband has been collected. Each user's data set includes a features file and a label file. In the feature file, each row corresponds to all sensor values at a certain moment. The label file records the date, users, postures, and the corresponding moment in the feature file. Both files have the same number of rows and each row corresponds to each other. In the feature file, there are 41 columns of the feature attributes as shown in the following table. For sensor 1, among the 30 data features, there is a 1 temperature data, 3 types 1 3-axis accelerometer data, 3 times 2 3-axis accelerometer data, 3 3-axis gyroscope data, and the 3 3-axis magnetometer data, as shown in the following table. And our task is that assume there's a new user, and the sports website has collected their motion data through sensors. How can we determine the state of these new users based on the collected data? Furthermore, for the same user, if the new data is collected by the sensors, how can we determine the current data of the user based on the new data? Here we have the programming idea. First, we create 5 folders A, B, C, D, and E in the current program directory. Each folder should store the features data file and a label data file for one of the 5 users. For example, folder A should contain 2 files, A point feature and A point label. Secondly, we use the pandas library function read
CSV function to read the content of each file.
In this function, specify that the delimiter is a comma. Missing values are represented as question marks, and the files do not contain header rows, and place this function within the loop. Sequentially read the content of all files. And finally, the FOD. Load all data from the feature files and label files into memory. Since there are missing values, you will need to perform sampling missing values handling. Specific steps are as follows. First, we should write a data import function, which takes 2 parameters, feature path, a list of feature file paths, and label paths, which is a list of label file paths. It defines a feature arrays a variable within a column count consists with the feature dimensions, which is 1. And then we define an empty label of variables with a column count,
consistent with the label dimension, which is 1.
Then we use the pandas library read CSV function to read a feature file, specifying the diameter as a comma, missing value as question marks, and indicating that file doesn't contain the header rows. Use the imputer function, setting the strategy parameters to mean
to impute missing data using the mean.
Use fit to train the preprocessors and transform functions to generate the preprocessed results. And we add the preprocessed data to the feature attribute set and iterate through all features files sequentially. And then we process the label files, which is similar to processing the feature files. First, we use the pandas library read_sce function to read a label file, and specifying the diameter as a comma and indicating that the file doesn't contain header rows. Since label files do not have missing values, you can directly add the newly read data to the label collection. Iterate through all label files to obtain the label connection labels. Finally, merge the feature connections feature as the label connections label. And in the fourth step, we split the dataset into train set and test set. First, we use the train test split function and set the test size to 0.1 to randomly shop the data, making it suitable for initializing and training classifier later. And then receive the data path, feature path, and label paths using the Python slicing method to extract the first 4 values from the data paths as a training set and pass them as argument to the load dataset function to obtain the training set's features xtrain,
and the training set's labels ytrain.
Use the last values as the test set and pass it to the load dataset function to obtain the test set features xtest and the test set labels ytest. And then recreate class for KNN decision tree and naive Bayes and train them using the training data. Create KNN classifier, decision tree classifier, and
Gaussian naive Bayes classifier with tier default parameters.
Feed these parameters with the train data xtrain and ytrain.
And save the trained classifiers in variable KNN DT and GMB.
We use the taste set xtaste to make predictions with the classifiers and compares the predicted values with the actual labels to calculate the overall accuracies and recall of the model. And then use these metrics to evaluate the model's performance. We can achieve our going cyclers using the following code. First, let's import the libraries we need, and then we use the following code to create our dataset. And next, in the main function inside the PyCharm IDE, we will proceed with our model training. Finally, printing out the training results. We won't provide detailed explanations of the code here, as we encourage students to explore it on their own. Alright, our machine learning class concludes here. We hope that everyone is interested in machine learning.